Welcome back to Applied Physics Lecture Series, Unit 4, Lasers, Lecture 1, Characteristics of Lasers and Applications. First of all, you have to know what is the abbreviation of laser. So the abbreviation or acronym of laser is light amplification by stimulated emission of radiation. By observing this abbreviation, very easily you can able to understand light is a kind of radiation. Like all other light radiations, it is also a kind of electromagnetic radiation. And here the amplification takes place. Amplification means with minimum input, we have to get maximum output. That kind of process is involved in the generation of laser light. And the process of laser emission, that means we are getting light entirely through the process of stimulated emission. That's why the word stimulated emission is also included in the abbreviation of laser. That's why the acronym for laser is light amplification by stimulated emission of radiation. Here we have to compare laser light with our conventional light or normal light. So by making such a comparison, so ordinary light and laser light, so the main features related to the ordinary light are spontaneous emission, incoherent, divergent, polychromatic, cannot be focused to a sharp focus. What is meant by this spontaneous emission? Usually the electrons in any kind of material are present in the ground state. Once the process of absorption or excitation is over, the electrons are reached to the higher energy level. But the electrons are not present on the higher energy level on a permanent basis because gradually their energy will be reduced. As a result, by emptying certain amount of energy spontaneously on its own, after the lifetime is over, they return back to the ground state by releasing certain amount of energy. Such a process is called as spontaneous emission. So without any external agency, spontaneously on their own, once their lifetime is over, they return back to the ground state by releasing certain amount of energy. So here's a release of certain amount of energy is usually takes place in terms of photon amount of energy. That means by releasing one photon amount of energy, one HU amount of energy, electrons present in the higher energy level are returned back to the ground state on its own. Such a process is called as spontaneous emission. The photons which are released during the spontaneous emission are incoherent photons. What are incoherent photons? The photons which are having same energy, but they are traveled in different directions. As a result, we can't able to maintain constant phase difference between them. Such a photons are called as incoherent photons. Always spontaneous emission produces such a incoherent photons. Therefore, the basic principle behind the production of any ordinary light is the process of spontaneous emission. So second one is it is incoherent. Already I mentioned. So during the process of spontaneous emission, we are getting incoherent photons. And incoherent photons are traveled in different directions. That's why the ordinary light radiation is divergent. It is possible to travel in all possible directions. It is traveled in all possible directions. That's why it is divergent. And polychromatic. Usually from the ordinary light, we are getting white light. White light consists of all possible 7 colors like VGR. So poly means several. Chromatic means several colors. We are having several colors. Usually we are having 7 colors. So it is a polychromatic. So because of this divergence, so it is ability to travel in all possible directions. So it cannot be focused towards a sharp focus. So it is deviated in all possible directions. But if you take the laser light, so the process behind the emission of laser light is stimulated emission. What is meant by stimulated emission? The word stimulated means we have to induce. So with influence of certain amount of external agency, once the process of absorption is over, certain number of electrons are present in the higher energy level. So before the lifetime is over, forcefully we brought back the electrons to the ground state by releasing certain amount of energy. Such a process is called as stimulated emission. So to start the process of stimulated emission, external agency is required. Here, one photon amount of energy will be acted as external agency. Such a external agency will act on the electrons which are present in the higher energy level. As a result, electrons are returned back to the ground state by releasing another HU amount of energy. As a total, 2 HU amount of energy is released by the transfer of one electron from higher energy level to lower energy level. Such electrons are coherent electrons. Why? Because all are having same energy and those are traveled towards one specific direction, and because all those are traveled in one specific direction, we can able to maintain constant phase difference between them. Then such a photons are called as coherent photons. Therefore, always stimulated emission produces coherent photons. Then laser light consists of only coherent photons. And the third property is highly directional. So here all the photons, here we are having coherent photons. All such a coherent photons are traveled in only one direction. That's why you can able to focus towards a specific direction. So that's why you can able to say it is highly directional. And monochromatic. What is meant by this monochromatic? So the light radiation which is coming out during the process of stimulated emission will contains only one color. Out of all the radiations available in the universe, only laser light is having the ability to maintain highly monochromicity. So we are getting only one color light radiation. The traditional color of laser is nothing but red. Because of the directionality, all the photons are traveled towards one specific direction. We can able to focus the laser light towards a very sharp spot. Then what are the characteristics of lasers? So out of all the characteristics which are exhibited by the laser, we will identify four as special characteristics. Those four are also called as striking features. Those are nothing but directionality. So here directionality means unidirectionality. So laser light is always traveled in only one direction. That's why this directionality will be also called as unidirectionality. Second characteristic is high intensity. Third one is monochromicity. And the last one is coherence. We will see all these characteristics. I will explain now in detail. So what is meant by this directionality? So already I mentioned laser light consists of coherent photons because those are coming out during the process of stimulated emission. As a result, we are having coherent photons. They have the ability to travel only one specific direction with less deviation. That means from the source where it will be produced. So that will be coming out with less deviation. That is nothing but directionality. So very tight beam, which is very strong and it is concentrated. So the directionality of laser beam is expressed in terms of angle of divergence. So what is meant by this angle of divergence? It is twice the angle made by the outer edge of a laser beam with the axis of the laser beam at the center of the laser light. Simply, you can able to say it is twice the angle made by the outer edge of the laser beam at the axis of the laser beam with reference to the emitting source. So the divergence or angular speed is given by the formula phi is equals to r2 minus r1 by d2 minus d1. Here d1 and d2 are the two distances from the laser source emitted, and r1 and r2 are the radii of beam spots at a distance d1 and d2 respectively. So it is shown in the previous slide figure. So laser light has less divergence, which means that laser light has more directionality. Then coming to the second characteristic, high intensity. In case of lasers, all the photons, which are nothing but coherent photons, are traveled in only one specific direction. That's why they will occupy very less space. And each photon energy is h nu, and all the photons are traveled in a specific direction. Therefore, you can able to add the individual energies of the photons on a constructive basis. That means h nu plus h nu plus h nu leads to a huge value. This entire energy will be concentrated within a small region. Thereby, the concentration of energy within the small region accounts for high intensity. That's why the concentration of energy within a small region accounts for greater intensity for laser light. Then monochromacity. So monochromacity means one specific color. So the output, that means the light which is coming out from the laser is exhibiting only one color. Why it is? So in case of normal light waves, so multiple wavelengths, all the possible VIBGR, violet, indigo, blue, green, yellow, orange, red, all the possible wavelengths are coming out, and those are diverged into all possible directions. That's why we can able to say those are not parallel and dispersed. They are traveling multi-direction. But in case of laser, because by the presence of coherent photons, so all the photons are traveled in only one direction. That's why they are parallel and non-diverging, and they are traveled in only one direction. That means unidirectionality is possible. Thereby, they are having only one wavelength, that is monochromatic. Then what is meant by coherence? Simply, coherence will be defined as any two. If any wave appears as a pure sine wave for infinite long and infinite space, then it is said to be perfectly coherent. Practically no wave is perfectly coherent, including lasers. But when compared to the other light sources, lasers have high degree of coherence because all the energy is concentrated within the small region. Therefore, we are having two independent concepts related to the coherence. One is a temporal coherence and second one is spatial coherence. If we measure the coherence of a laser light by taking time as a criteria, then it will be called as temporal coherence. And if we measure the coherence of a laser light with reference to space or distance as a criteria, then it will be called as spatial coherence. Now let us see what is meant by this temporal coherence and spatial coherence. The two wavefronts of any electromagnetic radiation are maintaining constant phase difference only during the observable period of time, then those two wavefronts are said to be in coherence with reference to that specific time point. That's why that type of coherence is called as temporal coherence. You can able to see the property of coherence in case of this diagram, especially on the right hand side. See, the distance between the two consecutive crusts are exactly same. That is the meaning of coherence. And in this diagram, you can able to see the coherent light, which is propagated uniformly, but incoherent, which is nothing but LED light. It is possible, it is traveled in all possible directions. Then what is meant by this spatial coherence? The two wavefronts of electromagnetic wave, they have to maintain constant phase difference over any location, any distance. That means here time has no criteria, irrespective of time. If you consider any two wavefronts of the electromagnetic radiation, they have to maintain constant phase difference. Then in such a situation, we will identify the type of coherence as spatial coherence. Achieving spatial coherence is a little bit difficult when compared to the temporal coherence. Then coming to the applications of lasers, we are having so many applications with respect to the laser light in our daily life. So there is a wide range of applications. So if you observe in this diagram, in this PPT, so where are you going to use this laser light? In the area of communication, in the area of material processing, in the area of lithography, and in the medical applications, instrumentation and sensors, optical storage, R&D military applications, display applications, printing applications, like this we are having, even agricultural applications. We are having so many wide range of applications. Out of those, we will discuss very few applications in detail. uh, so because of this wide range of applications we are having with laser, so laser light nowadays becomes very, very important. So if you identify the applications of lasers in the field of communication, lasers are used in optical communications due to the large bandwidth, because all the photons are traveled in one direction. They are occupying less bandwidth. Therefore, as a result, they are occupying less space. As a result, they offer high bandwidth. The laser beam can be used for the communication between Earth and Moon, or in between Earth and other artificial satellites due to the narrow angular speed. So it has the ability to travel long distance with small reduction in the intensity. So that's why nowadays we can able to use laser light to find out the distance between Earth and Moon, or in between Earth and other artificial satellites. Used to establish communication between submarines. So usually, submarines are traveled underwater. So underwater communication also we will use the laser light. Under the area of medical, so for the removal of cataract in eyes, and used to detect the used to detect and remove the stones in kidneys, and use it to detect tumors in the brain. So these are the applications of lasers in the area of medical field. And in the industry, welding purpose, cutting purpose, drilling purpose, in the agricultural purpose, if you treat the seeds with a laser light, so all the harmful germs and all those are died. As a result, the role of using pesticides will be minimized for the separation of isotopes, counting of isotopes, hydrogen storage. So security purpose, these are all the different applications of lasers in almost every area. Thank you for watching.